Awesome. Cool. Well, thank you for coming. I appreciate it coming out on a night where there's beautiful sunshine and football. I appreciate the new faces in the room. Tonight is, I think, the first Brighton jug in quite a while, actually. So it's nice to kind of get back up and running. Tonight we've got Bas, who's a test automation consultant. I've been looking forward to this talk for a little while. I've been kind of talking with Bas around kind of his training that he does on APIs and API security. A little bit close to home for me because Bas does a lot of work in the kind of YMOC community as well. So I'm kind of looking forward to this talk on contract testing tonight. Cool. I'll grab one of those. Can you just flick the... Cool. So tonight we've got the talk. We've got a few introductions to do from the Silicon Brighton team. Every time we do these talks, they're only made possible by people like the Silicon Brighton team here, but I'll let these guys introduce themselves, and also places like Runway East, the venues and this team make all of this possible. Do you want to do your Silicon Brighton bit and then...
Thank you very much. Yes, I'm Charlie. For those of you guys who have not had the pleasure to meet yet, I work in events and community engagement for Silicon Brighton. And first thing you need to know is that this event is being recorded. If you don't want to be included in any of the content, just let me know. And I want to start off by giving a huge thanks to Runway East, who are hosting us here tonight. We host about one event a week here now, which we absolutely love. It's a fantastic space. And they also very kindly sponsor the pizza as well, which is fantastic. At Silicon Brighton, we're the host of Brighton and Hove's tech sector, and we support over 30 different groups across the city, different meetup groups within the tech and digital sector, including Brighton Jog and also Brighton Kotlin, but also many others that you can see here. All the events that we run are free to join, available to people at all ages, and they're all hybrid, so they're obviously in the room, but we run a live stream on YouTube where we can make a video of the event afterwards as well. And none of the work that we do would be possible without the help of our amazing supporters, all of whom you can see on the screen now. And if there's a company who you know who might be interested in adding their names to that list, please do point them in our direction. We would really appreciate it. I'd like to give a special shout out and special thanks to Octopus Energy, James Chase, Hyperion Dev, and the University of Sussex, all of whom are our sponsors, who play a huge part in helping us do all of the work that we do. They are absolutely fantastic. We're always looking to collaborate and work with everybody as much as we possibly can. So if you might be interested in coming doing a talk at an event or helping a meetup organizer, helping Lee, for example, with organizing the events, then please do get involved, speak to myself or a meetup organizer, and we can put you together with whoever you should be talking to get you involved. If you want to stay in touch on socials as well, we are at Silicon Brighton on LinkedIn, Instagram, Twitter /X, and TikTok. And the events we've got coming up are Brighton AI tomorrow night, also Ladies That UX in Brighton tomorrow night as well. There is a conference at the Dome for Brighton Ruby on Friday. And then if you want to go on after that, there's game dev drinks in town as well. So lots of stuff going on. The best place to stay up to date with all the work that we do is on our Slack community. And if you scan this code, you'll be able to access the events page, the Slack community, and everything that we've just gone through there. So yeah, please do so. That is everything from me. Thank you very much for coming and for tuning in. I'm going to pass back to Lee, who's going to intro Bas.
Awesome. I won't hold us up any longer. I think we'll get straight into the talk. If there's any questions that come through, we can kind of go through them at the end. If anybody's got any questions online, then I'll gather them up and ask towards the end. So without further ado, over to Bas.
Hello, hello, hello. Can you hear me all right?
Hey, yeah, we can hear you.
Awesome. And I think I started sharing my screen already, which means you should be able to see the world's ugliest slides. Could somebody please confirm that it's so?
Yep, we
Lee?
can hear. We can see the slides.
Awesome. So first of all, thank you for having me. Thank you for the invitation, Lee. Really appreciate it. This is a subject that's very dear to me, contract testing. So I appreciate all the opportunities that I get to talk about it, to show to people how it works, what it is, and mostly what problem it tries to resolve. My name is Bas. I'm based in the Netherlands. I was sort of kind of planning to join you live and in person. Unfortunately, that didn't work out, which I'm especially sad about now, having seen that disco ball in the background. Anyway, I'm Bas. As Lee said, I'm a test automation consultant and trainer. I'm based in the Netherlands. I've been in testing and automation for some 18 years now. Doing lots of different things, working with lots of different clients, different tools, tech stacks, languages, everything, really. But tonight I wanted to talk to you about contract testing. And contract testing is, over the last couple of years, it has seen a massive rise in attention and interest. I see lots of people talking about it, lots of people claiming they do contract testing, lots of people actually doing contract testing, and lots of people thinking they do, but not really understanding what contract testing is and the problem that it tries to solve. So that's why I came up with this talk, as well as a live demo of how it actually works in practice. So contract testing is a test technique supported by tools. The first thing I typically mention is that it doesn't replace unit tests. It doesn't replace functional acceptance tests. So doing contract testing does not absolve API developers from doing loads of good testing themselves. So contract testing is a technique that's complementary to these other types of testing. And it's something that's especially relevant and especially interesting for those kinds of systems, those kinds of application landscapes that are highly distributed in nature. Some people immediately link contract testing to microservices, which I'm a little bit wary of, because I don't really know what microservices are. And if I ask others about, give me a definition of a microservice, if I ask 5 people, I get about 6 different definitions. But it's a problem. It's a technique supported by tools that helps address a problem, that helps tackle a problem in testing of distributed software systems. And those might be microservices based. One of the biggest challenges of testing in distributed software systems is getting an answer to this question. All these individual components and services that are typically developed in different teams, different departments, sometimes even different companies, every component, every service has their own software development lifecycle, their own product backlog, their own issue list, their own release calendar. And the more distributed your system becomes, the harder it is to find a timely answer to this question. All these individual components and services, the fact that all these components and services work well in isolation do not mean they work together quite as well. So we need to do integration testing or end-to-end testing or whatever you want to call it. So, for example, and you'll see these examples again in the code base, I have a service that manages address data. There's a team that's responsible for developing, testing, and delivering that service. And hopefully they do lots and lots of testing. That can be unit testing, that can be functional testing, acceptance testing, it can be performance testing, it can be security testing, all these kinds of things. I hope they do this, and I hope they do this a lot. That's not what contract testing is about. What contract testing is about is the fact that this service will be consumed by other services or components in a distributed software system. So, for example, within the context of this talk and the demo that I'm giving, that address service is going to be consumed by another component that's responsible for managing orders, as well as a component that's responsible for managing customer data. And both the order consumer and the customer consumer services have expectations about the behavior of the address provider. They expect the provider to behave in a certain way in certain situations. That's why we do integration testing, to see if reality matches those expectations. And there can be differences between what these consumers expect and what the address provider actually returns. So a couple of quick examples. Maybe they expect a response, for example, when they're retrieving address data, a response with a field type that has a value delivery, but the address provider doesn't provide it. Or maybe they expect that field and it's returned in a slightly different formatting, slightly different way of formatting that value. This is especially interesting when you get to dates and times, of course. So maybe the consumers expect dates and times to be formatted like this, but the service returns them in a slightly different format, causing all kinds of interesting situations on the consumer side. And then there might be differences between the expectations of individual consumers. So maybe the order consumer for a certain operation expects an HTTP 200, whereas a customer consumer expects an HTTP 201. Or maybe the order consumer expects a date field to be formatted like this, whereas the customer consumer expects it to be formatted in a different way. This is why we do integration testing, to find out if there are any issues in the integration between a consumer and a provider at any given place in your distributed software system. Now, the traditional way that we, and when I say we, I mean we as testers. Again, I've been a tester and in testing for 18 years. So when I say we, I mean we as testers. We've traditionally tried to use the what I call the everything at once approach to integration testing, meaning that if I have a software system that consists of components A, B, C, and D, I am going to frantically try and get A, B, C, and D in a certain state with a certain version, with a certain configuration, with certain data into some kind of shared testing environment and try to do integration testing. Well, if you have 2 or 3 components, that is manageable. If you have 150 different components, that's going to be a pain. If you have thousands of components, it's going to be impossible. And even if you get this to work, even if you get A, B, C, and D into some kind of shared testing environment at some point in time, it's typically going to be very late in the process until both A, B, C, and D are mature enough, ready enough to do the testing that you want to do, which is typically either very late or just never. This is where contract testing comes in. Contract testing tries to address this problem. And it tries to address this problem by proposing a new way, a different approach to integration testing and to end-to-end testing. And it's different from the traditional way in a couple of different ways. First of all, instead of focusing on everything at once, contract-based integration and end-to-end testing focuses on the integration of individual consumer and provider pairs. So instead of checking are A, B, C, and D able to communicate with one another, it tests is A able to communicate with B, is B able to communicate with C, and is B able to communicate with D. So it breaks up that puzzle of integration testing, of large-scale integration testing, into smaller and hopefully more manageable pieces. So that's one difference. The second one, and I think the more important one, is the fact that traditional integration and end-to-end testing is synchronous. And by synchronous, I mean, if I want to test the integration between consumer A and provider B, consumer A and provider B need to be in some kind of shared testing environment. And if that happens at all, it typically only happens very late in the process. Contract-based integration testing is asynchronous, meaning the consumer and the provider still have their respective responsibilities, but they can do that as part of their own local build, development, testing cycle. Because if I want to test the integration between consumer A and provider B with a contract-based testing approach, consumer A and provider B do not need to be in the same shared testing environment, which also saves you a lot of effort setting up and running and managing the testing environment and everything that's deployed into that testing environment. If I was a marketeer, I would probably call this shift left. So contract testing shifts left integration testing efforts, or as I prefer to put it, it brings integration testing efforts to the front and breaks it down to essentially to the local unit and acceptance testing level. We'll see more about that and how it exactly works in a demo. There are a couple of different approaches to contract testing. Not a lot of people that I talk about that I talk to about contract testing don't really know that. They only know one way because they know one tool, and that's the consumer-driven contract testing approach, which is popularized by Pact, which is also the tool that we're going to see in the demo. And Pact is a great tool, but this is where people and teams typically skip a step in the process because they immediately jump to, let's try Pact, which means let's try a consumer-driven contract testing approach, which might not be the best approach to their specific context, for their specific context. So there's consumer-driven, there's obviously then also provider-driven contract testing, and there's a relatively new approach, different approach to it, which is called bidirectional. I will talk about consumer-driven contract testing. I'll also talk about bidirectional contract testing. What I will not talk about too much is provider-driven contract testing. So the way the consumer-driven contract testing works is a consumer generates a contract containing the expectations about the behavior of a provider. So a contract is a set of agreements, set of expectations from one consumer about one provider. So if a provider is consumed by 5 consumers and they all do consumer-driven contract testing, the provider needs to verify that it can meet the expectations in 5 different contracts. And yes, there can be conflicts of interest, which is exactly what this type of testing is about, to find out these conflicts of interest and make people talk about them and solve the issue. So a consumer generates a contract, publishes it to some kind of central contract repository. Provider downloads it, verifies whether it can meet the expectations, publishes the verification results, and that information can then be used by both the consumer and the provider to check, is it safe to deploy into an environment that might just be your production environment. Provider-driven contract testing is very unidirectional. It's the provider saying, this is what I do, this is my contract, publishes that contract. Consumer can check that contract, verify it, but there's no feedback loop. There's no conversation. It's basically just the provider saying, this is what I do. And then there's bidirectional contract testing, in which both the consumer and the provider publish their own version of a contract. And then it's the contract repository that does the matching, that does the verification to see if there are any mismatches between the expectations from the consumer and the actual behavior from the provider. We'll talk a bit more about it at the end of the talk. And I completely forgot to ask you, Lee or Charlie, we have a sort of kind of a hard cutoff time, I think, which is 9, because that's when the football starts. Do you want me to wrap this up at a certain time just before the football, or what did you have in mind?
No, I think we're all good.
Awesome.
Thanks, mate.
So the consumer and provider both publish their contract. The repository actually does the verification. And again, just like with consumer-driven contract testing, both the consumer and the provider can use that information to see if there are any known integration issues and if it's safe to deploy. And this, the right approach to take should be the first question when starting to think about contract testing. What is the approach that best fits my context, my integration? And again, I see so many teams and organizations immediately go for consumer-driven contract testing because they've heard of Pact. And again, Pact's a fantastic tool, but there are contexts and situations where Pact is probably not the best choice. And I'm saying that the fun fact is also the people who develop and run Pact say the same thing. Well, our tool works and it works fine, but it's probably not the best solution to every integration testing problem. We'll talk a little bit more about that too, about when consumer-driven contract testing works well, when you might want to go for bidirectional or some other kind of contract testing approach. I've got some links in this slide deck, which I don't expect you to remember or to write down very quickly. I will share this slide deck with Lee afterwards. Lee, I don't know if you have a place to publish it, but at least you will have the slides afterwards. So people can revisit them and see the links or, So first up is consumer-driven contract testing, which again is a technique supported by tools that helps you write down, formalize expectations that a consumer has about the behavior of the provider in contracts. And it also provides tooling that can help check that the providers meet those expectations. Lovely thing for the provider, biggest benefit for the provider is they have a safety net. They have an additional safety net because they already had, hopefully, the safety net of their own tests that they wrote against their interpretation of how they should behave. But now they have an additional safety net in contracts that contain expectations from their actual consumers, which means that as long as they can demonstrate that they still meet all of the expectations from the consumers, they can pretty much do whatever they want. They can add new features. They can remove features. They can refactor code. They can rewrite everything from scratch if they want to. Because they have this safety net, they know that, of course, this is not a guarantee that there are no integration issues, but at least they have an additional safety net. And of course, for consumers, it's also a great way to build trust in providers because the providers demonstrate that they can meet the expectations that are sent to them through the contracts by the consumers. Tools. There are two major consumer-driven contract testing tools out there. The one is Pact, obviously, which is also the tool that I'm going to show in the demo. Pact's available for a wide range of programming languages. This is not a complete list, by the way. There's also C++ and a couple of others. It's open source, it's free. Docs are excellent at docs.pact.io. The only other true consumer-driven contract testing tool that I know of, which might actually be interesting for this audience, is Spring Cloud Contract. Which obviously, and you probably would have guessed that by the name, is not only Java only or JVM, Java ecosystem only, but it's part of the Spring ecosystem, which means that if all of your services and components are Spring-based, Spring Cloud Contract might actually be a very interesting alternative, a very interesting option for you. I don't know. I've never used it. I just know it exists, which is also the reason why I chose Pact. The nice thing about Pact 2 is that the contracts are compatible across the different bindings, across the different languages. So if my consumer is written in JavaScript, because it's my front end, for example, that can generate a contract, which can be verified by a provider service, a backend service, for example, written in Java or C# or Go. That's because the contracts are interchangeable. So the way Pact works is we have a consumer generates a contract. That contract, what Pact does as a nice little bonus is generate a mock provider that behaves exactly according to the expectations written in the contract, which the consumer can then use to test its own implementation. So it's also a provider mocking tool. If you're going to only use it as a provider mocking tool, you probably want a different provider mocking tool, because this is just nice to have. The actual interesting thing, of course, is passing this contract to the actual provider, where Pact tooling can replay all the interactions in the contract using a mock consumer against a real provider and check that the real provider returns responses that are compatible with the expectations that are written down in the contract by the consumer. To distribute these contracts, we need a Pact broker. So we could do this by hand, and versioning by hand, keeping track of verification results by hand. That's boring, error-prone. Nobody wants to do it, so please don't. The way to do this, the way to automate that process is by using a Pact broker. A Pact broker takes care of a couple of different things, namely the automated distribution and versioning of contracts. So you don't actually verify a contract, you verify a version of a contract. So contracts are versioned too. So verification results correspond to a certain version of a contract, not to a contract in general. And of course, it also stores and distributes contract verification results, which again contain information about whether or not the provider is able to meet the expectations from the consumer that are written down in the contract. There are two Pact broker flavors. One of them is an open source Pact broker, which is available as a Docker image. It's free, it's open source even, but it has a number of it's relatively limited in features. For a lot of companies, it is good enough. But if you want something like role-based access control, or if you want bidirectional contract testing, the open source Pact broker is not going to support that. In that case, you'll need PactFlow. PactFlow is a commercially licensed Pact broker. It's also, full disclaimer, the one that I'm going to use in the demo. It has a free plan, So what you'll see in the demo, I'm using the free plan. I don't pay for Pact Flow. I don't get paid to show Pact Flow, which is also not unimportant to tell you. It's just that it's cloud-based. It's much easier to set up, and it looks a bit nicer. So with demos, it just works easier. But everything I show you in this demo, we can do with the free plan of the commercially licensed Pact Flow. So again, the way this works, I have a consumer and a provider and a broker, and the consumer publishes a contract. The provider downloads that contract, verifies whether it can meet the expectations, publishes the verification results, and then both the consumer and the provider can check the verification results to see, are there any known integration issues. Let's have a look at the code, finally. So I was told that this is entirely readable for you on the screen right there. So I have a test class here. So I have a little project with 2 consumers and 1 provider. And for the consumer, I have some tests here that record, that specify the expectations that the consumer has about the behavior of the provider when it's retrieving an address using an HTTP GET, using an address ID, which is a UUID as a path parameter. And it distinguishes a couple of different situations. The first one is immediately the most interesting one, which is what happens if there's an existing address. So what happens in the HTTP 200 situation? Now, in that case, I expect a status code 200 in the response. And I'm also expecting the response to look to have a certain shape, to look a certain way. So, for example, I expect a field address type to be in the response, and the value should be a string. I expect the number field to be in the response, and I expect that to be an integer. I expect an ID field to be in there, which should be a UUID, which is just a utility method that basically resolves to, it should be a string, but not just any string, but a string that matches a certain regular expression. There's also examples specified here. These are purely used to populate the mock response for the mock responses that the mock provider that Pact generates will return. This does not say, you should not read this as, when I send this address ID, I expect the value of the address type to be billing. I could do that. I'd need a string value matcher in that case instead of a string type. Please don't do that. Please don't try and do functional testing through contract tests. Please only check that, in this situation, I'm expecting a response that's shaped like this, and I need this shape because otherwise I can't parse it. Don't be too strict. Don't expect certain values to be in there, because that A, creates very inefficient acceptance tests for the provider, and B, it creates a lot of coupling between consumer and provider with all kinds of interesting but not necessarily desirable results. What I also need to specify is a provider state on the consumer side, which means that, dear provider, before you verify this interaction, please make sure that an address with a certain ID exists. This is one of the things that provider teams don't really like about consumer-driven contract testing. All these provider states that are dictated or forced upon them by the consumers. I also have a couple of different situations. What happens if the address ID doesn't exist? Well, the only expectation I have is about the status code in that case. As well, what if the address ID that I'm specifying as a path parameter is not a valid UUID. I expect an HTTP 400. I have some other tests here. When I run them, I took the liberty of running that pre-starting the talk because my IntelliJ has the annoying habit of sometimes getting very slow when I'm also sharing my screen. So what happens if I run the tests? You just have to believe me on this one. I will do the provider verification live, so don't worry about that too much. So what is generated after the tests pass is a contract, which contains 1, 2, 3, 4, 5 interactions in a contract between the customer consumer and the address provider. The most interesting one is this one, again, the HTTP 200 for the GET, which this is the mock response that will be returned by the mock provider. And the matching rules is what is going to be verified by the provider. So what is going to be verified is, there should be an address type field in there, and the value should match the type of the example. The syntax is a little bit weird sometimes. The good news is this is all generated. You don't have to write it. You don't really have to read it either. So, and it works. I've got an ID field, again, that should match this regular expression, which is a regular expression to see if a string value is a valid UUID, and so on and so on. So the first thing I need to do as a consumer, when I've run my tests, when I've generated a new contract, is publish that contract to my Pact broker, which you'll see right here. Let's do that. You'll see Maven Pact publish. This is just some Maven tooling that helps with, basically just performs an API call to Pact Flow and publishes the contract. There we go. It is a little bit slow, but it will, I said it does, publish the contract to the provider. It just takes its merry time for a bit, of course. This should be it's just, the only thing it needs to do is publish this JSON file. So it has done so. And when I refresh my broker, it's getting, my apologies for this. I have no idea how to fix this. I've seen this before. Anyway, I have a contract now published by the consumer, by consumer version 1.0.0. It's not yet verified, of course, because the provider hasn't done anything yet. But I can have a look at what's in the pact. And if I do that, I'll see that there are 5 different interactions in there. Once it has finished loading, there we go. There are 5. Oh boy, now Chrome is properly freezing on me. Can you still hear me, Lee?
Yep, we can still hear you.
All good?
Yeah, all good.
Okay, now Chrome just froze. The problem is StreamYard also runs in Chrome. But I'm still here. Good. So I have these 5 interactions here that are generated by the consumer. Let's switch over to the provider side, where I have a single contract test that this does a lot of stuff. Yay for Spring too. So it spins up an instance of my provider service. I tell it where to find the contracts, and I tell it to verify all the interactions that are in the contracts that are published to the broker. And then there's a method for every provider state that is dictated by the consumer. This is one of the things where providers are a bit wary of consumer-driven contract testing, because what happens is if the consumer includes a new state without informing the provider about the existence of that new provider state, the provider tests will fail because they say, well, I don't know how to respond to this new provider state. So consumer-driven contract testing is very powerful, but you still need to talk to one another, and you still need to inform providers about, hey, this is, or just agree upfront about the kinds of provider states that the provider can support, for example. Anyway, in this case, because my provider implementation is laughably simple, I don't need to do anything, and it will still pass everything. But typically, here maybe you would do some kind of database setup or a mock database setup, so you don't need to have an entire database and all the downstream services available. You can mock whatever you want, as long as you're confident that what your provider returns when it's running this test is the same as what your provider will return in production. So by all means, do a bit of mocking, but be very, very, very careful with it. Like every time you do mocking, really. Yes. So this command runs the test on the provider side. I'm setting an extra flag to automatically publish the verification results to the broker. And I identify the Pact provider version. So I need to specify that explicitly because when I run my tests this way, otherwise my provider would not publish the verification results. So what it's going to do now is, first it's going to take its merry time compiling my code. Once it starts running the tests, it's going to download this as of yet unverified contract from the broker, replay all the interactions against a real running instance of the provider, check that the responses returned by the provider are meeting the expectations that are written into in the contract by the consumer, and publish those verification results back to the provider. So again, that takes, normally it's faster, but that's what happens. So it takes a while to spin up a Spring service. So there's still a lot of Spring stuff happening here, but that's because my provider service is actually a Spring service. I can still use Pact. That was not too bad. So now it has verified that all the contracts, all the expectations in the contracts are met, and it has published those verification results back to the browser, which you can see right here. And if I look at the matrix view, I can see that version 100 of the consumer is compatible with version 100 of the provider, which is then input for a later stage in the pipeline where, using the Can I Deploy tool, which is also part of the Pact ecosystem, I can query the Pact broker and see, well, I want to deploy this version. Are there, of either a consumer or a provider, are there any known integration issues that I should know of before I deploy? Let me very quickly change an expectation here. Just say, well, in case of a successful delete, I now expect the provider to return a 200 instead of a 204. Let's upgrade the customer consumer to version 101. Go back to the customer consumer. Generate a new contract. So I've I'm releasing a new version of the consumer here, version 101, which has some a change in the expectations. So in this case, it's a bit of a dummy change because it's just a change in an expected HTTP status code value. Of course, the mock is still going to return the 200 now for a successful delete, which means my consumer side tests all pass, and I can publish this updated contract to the broker again, which will, over time, lead to a new version of the consumer contract published to the broker. There we go. It's publishing. Hopefully it'll be a little bit quicker now. Yay. It's starting to warm up, which took a while given the temperature outside. So we have a consumer version 101 now, which is as of yet unverified. If we go back to the broker and run to the provider and run our provider side testing. So the provider hasn't changed. Provider is still version 100. Interesting little trivia fact is I could have in a real setup, I could even upon the event of a customer or of a consumer publishing a new contract, trigger a build on the provider side through a webhook. Consumers love this. Providers are very, very skeptical because if a consumer makes a mistake, for example, writes down incorrect expectations in the contract, or adds a new provider state that the provider is does not know of yet, this automatically triggers a provider build, a build on the provider side, and causes the provider pipeline to break because of a change from the consumer. So it works great when consumer and provider are very much in sync and on speaking terms, so to say. But a lot of this is one of the things that takes a lot of convincing to implement on the provider side. But the technology is there. So you can see I now have a failing provider test, which again could be generated by triggered by a consumer webhook, consumer firing a webhook. And I now see that consumer version 100 is not compatible with provider version 10. Consumer version 101 is not compatible, or there are potential integration issues between consumer version 101 and provider version 100. And I can even see which interactions are impacted and what the error message was. In a moment, please. I can see it's this interaction and this was the problem. That's how consumer-driven contract testing works. So come on. Yeah, there we go. Back to my slides for a bit. I've got some useful what I think are useful resources in the slide deck as well. So the docs are great. There's also a video series created by the people who created Pact, which to a large extent tell the same story that I'm telling today, but there's demos, there's a demo in Pact.js, and there's also how does this help remove some of your end-to-end tests. All of these videos are fairly short. They're all under 10 minutes. And they're a great watch. I've also written some stuff myself, but I won't bore you too much with that. But if you're interested, the links are in the slide deck. There are a couple of things that, so we've talked about consumer-driven contract testing. There are a couple of things that consumer-driven contract testing does not do very well. First of all, please don't use it to test the implementation details of a provider. Test that there are no integration issues between the consumer and a provider. That's what contract testing is for. Everything else is the responsibility of the provider development team. It also doesn't work with public APIs. Why? Because a public API, A, typically has no clue who their consumers are. And B, if they do, it's very hard to reach them and to convince them, oh, dear provider, listen to me, because there's typically going to be lots and lots of different consumers. In which case, it's the provider-driven contract testing would be much more suitable. But this does not work. This approach does only work if the consumer, if there's a relatively small number of consumers, and if consumer and provider are on speaking terms, basically. By the way, back to that failure that I just showed, what Pact does not do is point fingers. It does not say, oh, the consumer is at fault, or oh, the provider is at fault. It only shows you, well, there's a mismatch between consumer expectations and provider actual behavior. So it's probably a good idea to start talking to one another. There's also a blog post by the people behind Pact, telling them what Pact is good for and what Pact is not good for in their own words, which I think is also a pretty interesting read. Some challenges. Well, I talked about getting provider teams on board. Again, consumer teams love this. Provider teams, typically a little bit harder. Also, getting testers on board with this, and I should say getting a certain type of testers on board with this. And I mean the type of tester that is not very comfortable writing code, that is a little bit scared of unit tests. There's fewer and fewer of them, which is a good, but they're still, they do exist still. Getting those kinds of testers on board is a little bit harder because you perform the whole integration testing problem is broken down to almost the unit testing level, which means that you're solving a testing problem using development, and it's typically a developer or a technically inclined tester who's going to be the champion of this. And getting other testers on board with this is sometimes a challenge. But the biggest challenge is definitely getting the provider teams on board. This is why the team behind Pact came up with a new, more lightweight approach to contract testing, which is bidirectional contract testing. Big disclaimer, I think I mentioned this before. This is a Pact Flow only feature. The open source Docker-based Pact broker cannot do what you'll see in a moment. So this is the consumer-driven contract testing flow. We've seen that a couple of times. The bidirectional contract testing flow is a little bit more lightweight. So both the consumer and the provider publish their own version of a contract. The consumer contract, again, contains expectations about behavior of the provider. And the provider contract is just a specification of what the provider does. For the consumer contract, this could be a contract generated by Pact as we've seen before, as we've seen a couple of minutes earlier. It doesn't have to be. I'll show you a different way to generate a consumer contract in a moment. The provider contract right now can only be the only supported format right now is an open API specification, but that's so ubiquitous that'll be available for a lot of different providers. They are working on supporting more formats, but right now the only format that you can upload, that you can publish on the provider side, is an Open API spec. After both the consumer and the provider have published their contract, it's the Pact broker that checks for the compatibility, that has the matching logic, which also explains why this is a Pact flow only feature. And then both the consumer and the provider, just as with consumer-driven contract testing, can check, are there any potential integration issues here? And is it safe to deploy this specific version into, could be your production environment. Let's have a look. Let me, in the meantime, start Postman 2, because I'm going to need that in a moment. If all goes well, I have a new integration here. That's an integration between an order consumer and a payment provider, because, well, if I place an order, I probably have to pay for it. So my consumer order and my tests on the order consumer side now also contain tests for the payment service client. So for the client on the order consumer side, that invokes the payment provider. Again, the payment provider can be something like Stripe or Molly or Ideal or whatever, just the payment credit card provider, I don't care. Now I could generate my consumer contract using Pact, but there are other ways that are supported too. And one of them I wanted to highlight here, which is I can generate a Pact compatible consumer or a Pact flow compatible consumer contract from WireMock interactions. So I know I don't need to explain to you, Lee, what WireMock does, but I'm sort of kind of assuming that the rest of the, for those of you who don't know, it's an HTTP mocking library. And because you'll typically have these mocks in place already, it's very easy to plug in the WireMock Pact plugin, and once you run your tests, record all the interactions, all the requests that are going into your WireMock instance, and all the responses that are being returned. And after your tests have finished, generate a Pact contract, Pact compatible, Pact flow compatible contract from that. Why? Because my WireMock definitions, my stub definitions, will already contain information about the expected behavior of my provider, which makes them a very good source for a consumer contract. So what I've done here is I'm starting a new WireMock server. I'm adding some configurations here. And for every WireMock interaction that I've got here, I'm adding some metadata, which is used after the tests have run to say, well, these interactions belong to this specific pair of consumer and provider, which means they should end up in this contract. I've done this for all different interactions. So if the order ID is valid, it should yield the expected payment. If the order ID doesn't exist, it should throw an exception with a 404. And if the order ID is invalid, it should yield a 400. Very similar to what we did with retrieving the address ID. But as you can see, there's no Pact code in this, yet it will still generate a Pact flow compatible consumer contract. And this type of code and these types of tests, a lot of teams will have these in place already because they've been using WireMock or other types of libraries and mocking libraries or consumer libraries for a while. So all they need to do really is plug in this case, because we're talking about WireMock, the WireMock Pact plugin, and leverage their existing WireMock stub definitions and generate a Pact flow compatible contract from that. So it's still busy compiling, running the tests. But once these tests are run, that shouldn't take too long now. It will generate a contract. Ooh, takes a while. There we go. No, not long to go now. Lots of information that I don't really care about too much. Yay. I've got my pacts here, which is, again, a contract that looks very similar to the contract generated by Pact that we saw earlier, but this is entirely generated from traffic coming into and going out of YAML. I can, of course, publish this to my broker so that the broker can match it to a provider contract, which I will publish in a moment. So let me see if it arrived properly. And it should. And there it is. This is my consumer contract. Again, the interactions are in there. It's just waiting for verification here. I'm using Postman for a moment to publish my provider contract. There are other tools to do this too. Basically, it's just making the right finding out how to make the right API call, and you could do that any way you want to. This is a base64 encoded representation of my OpenAPI spec document. I'm telling it, well, it is an OpenAPI spec, it's YAML, and I need to publish some additional verification results, which basically is the provider telling, well, these are the tests that I ran, and these are the results. Pactflow doesn't parse them, doesn't do anything with them, but for some reason, they still require you to upload them. This just says gibberish. Here be test results, something like that. And again, in base64. When I publish this to my Pact broker, it says created, hooray. And if I refresh my view now, it should say that there's success. Yay, hooray. So, which means that also for this integration, this bidirectional contract testing scenario, right now there are no known issues. So we have a consumer version 1.0.0 and a provider version 1.0.0. Contract comparison says they are compatible. The consumer contract looks like this. And the provider contract is just the OpenAPI specification again. So bidirectional contract testing is a more lightweight way of doing contract testing. The good news for the consumers is, well, you can generate a consumer contract with Pact. You don't have to. The good news for the provider is all you need to publish is an OpenAPI spec. The consumer could even do that for you without you even knowing. So you don't even have to involve the provider. It's a good idea to do so, especially in case of potential integration issues. You want to talk to, inform the provider anyway, but you don't necessarily need to involve them to do the verification first. There are some downsides to this too, of course. So otherwise, everybody would be doing this. First of all is obviously you need Pactflow. And you probably need a licensed for a paid for version, because the free plan can only contain 5 integrations, which is not a lot. So if you want more features, if you want role-based access control, single sign-on, those kinds of integrations, and want to support more integrations and more users, you're going to have to pay for it. It is what it is. So again, the open source Pact broker cannot do this bidirectional contract testing thing. So that's one. Another one is more on the type of verification that's being done. I could, again, technically generate a consumer contract with Pact and include all kinds of elaborate expectations about, I see as a consumer, I expect an ID field and it should match this regular expression. That's completely ignored by Pact Flow because the only thing it will look at, because it's the only thing it can look at, is, does this provider operation return an ID that's a string? So more elaborate types of verifications or of expectations rather are just ignored, and what's left is basically do the expected field names match the actual field names, and do the data types of the expected fields match the data types of the actual fields in the provider contract. That's still pretty useful, but just a little bit less powerful than the consumer-driven contract testing way. But again, to do consumer-driven contract testing properly takes more work. The good news is you can pick that, and especially if you use Pact Flow, you can select the right or the best contract testing approach for individual integrations. So right now, for this integration, we used consumer-driven contract testing, and for this one, we did bidirectional. This information that's being used, downstream at a later stage in your pipeline, it's going to be the exact same thing. So you can do this. You can select the right approach. And by right approach, I mean either consumer-driven or bidirectional, almost on an integration by integration basis. So for one integration, consumer-driven testing, consumer-driven contract testing might be suitable. For another one, say, well, no, the providers are not really on board yet. So we start, for example, with bidirectional, and maybe that's enough. And maybe at some point they say, well, this is nice. We want more. Let's shift to consumer-driven. I've got some links about bidirectional contracts in the slides too. If you want to learn more about contract testing in general, I cannot recommend this resource enough. It's still in the early access program, which means it's not entirely done yet. It's not entirely published yet. But you can read, I think, the first 8. It will be 12 chapters in total. And I think at the point of, at this point in time, there's 8 chapters published. It's written by, 2 people who are completely independent of Pact, who are experienced contract testing practitioners, consultants. It has been written and reviewed by, contributions have been made to the book by the team behind Pact. It has been reviewed by the team behind Pact. So there's a lot of solid advice and a lot of trustworthy information in there. And that's it from me, basically. I think nicely on time, which leaves us enough time for a couple of questions, and for you to grab a drink and go for a toilet break before kickoff.
That was awesome, Bas. Thank you very much. That was really cool. Just a question around kind of getting started. If you're in an organization and you have like a large number of end-to-end tests and you're putting a whole load of kind of state together for each of your services and you want to start dipping your toe in the water, is there a good way to kind of do that? Is there a nice way to get started?
So the obvious consultant answer is it depends. The obvious, almost open door answer is start small and take small steps. What I typically do is, identify one critical integration or a few that have had integration issues in the past, because those feel the pain of not having sufficient integration testing the most. but a lot of it also depends on team dynamics, especially if you go the consumer-driven contract testing way. So I would say pick a suitable integration to start with and start small. But what constitutes a suitable integration varies from one team to the next. So again, that could be an integration that has seen a lot of integration issues in the past. That could be an integration where both the consumer and the provider are developed in the same team, which is by a reasonable margin the easiest way to start, but doesn't necessarily provide the most value, because the most value you will find on those integrations where consumer and provider are in different teams. Because if those are in different teams, the likelihood of integration issues because of misinterpretation of specifications is that risk is just much higher. And then it's also a matter, well, what type of integration testing should I start with? The people behind No Nirvana have published, and I have no clue why this is not in my slide deck, this URL, but it will be before I send it to you, Lee. This is basically a step-by-step guide written by the Pact team on how to get started. Again, there's not just one way to get started. There's a gazillion different ways, but this could give you a nice step-by-step introduction on how to do this. And they say, well, I love how they start with getting team alignment. Start talking before you start throwing tools at problems. Then get a single test working manually, pack brokers, start integrating that with your PR, with your CI pipelines, add can I deploy, and so on and so on. So this is also a nice resource, but a lot of it, unfortunately, I hate this answer, but I still have to, well, it depends on the context.
Sure, yeah, I understand. We've got a question from somebody online. I think it's up on the screen there. Basically around any potential risks around contract testing being done asynchronously in a kind of sync environment.
So the asynchronous part is it's completely unrelated to the integration itself being asynchronous. So the demo that I showed is for a synchronous integration, just an HTTP API. Pact supports message-based APIs as well. So that's one part of the synchronous, asynchronous. What I meant with asynchronous is that while both the consumer and the provider have tasks to have responsibilities in the contract testing process, they do not need to be in some kind of shared test environment at some point in time. So they do not live exchange requests and responses. Is there a risk to that? Yes. And there's two types of risk actually, and that is incorrectly defined contracts, basically the consumer forgetting to ask for what they really need, because then the provider can say, well, no, I can comply with that, and then the consumer said, oh crap, but I needed this too, but I didn't ask for it. So that's one. The other thing that you're losing here is the network configuration and setup, kind of, because there's no actual integration. There's no actual live exchange of messages or data between two systems. You don't verify that with this type of content, so you lose that information, which is also one of the motivations and the reasons I give. So this removes some of your end-to-end tests, maybe even a lot of them, but definitely not all of them, because you still probably want to have a couple of tests at some point in time that just exercise your system as a whole in some kind of shared environment. But with contract testing, you can find out and be informed about potential integration issues a lot earlier in your development and delivery process, if that makes sense.
Perfect. Thank you. So I think that's all we've got for questions. So thank you very much for your talk.
You're welcome. Thank you for having me.
No worries. I'll chat to you afterwards and get the slides and kind of send those out to everybody.
Absolutely.
Yeah, we'll take it from there. So I appreciate your time.
Thank you so much. And thank you for everybody, both over there in Brighton. Again, sorry I couldn't join you live. And also for the people online for taking the time out of your day or evening to attend this talk and listen to me. I appreciate it. Thank you.
No worries. We'll get the video published as soon as we can.
Awesome. Thank you so much, Lee.
Thanks, Bas.
Cheers. Bye-bye.
I don't think so. I mean, we've got some slides afterwards, have we? Cool. Then I think we're done. Thanks for your time, guys. I appreciate you coming.